From Studio A at the USC Annenberg School, this is Kirti Subramanian, your host for the Paradigm Podcast. Today, I'm super excited to be joined by Professor Angela Zhou, who is an assistant professor of data sciences and operations at the USC Marshall School of Business. Her work focuses specifically on how we can use data and AI to make better and more reliable decisions, especially when the data isn't perfect or there's a lot of uncertainty. She works specifically at the intersection of machine learning and causal inference and applies her research to areas like healthcare, public policy, and even online platforms. She also studies very important questions around fairness and responsibility in AI, particularly in very high-stakes situations like social services and even criminal justice. Before joining USC, she was a postdoctoral researcher at UC Berkeley and earned her PhD from Cornell University. Professor Zhou, thank you so much for joining us today on this podcast. To start us off, could you please give a bit of background on yourself and what really got you into this space?
Thanks, Kirti, for the invitation. Super fun to be here. Super excited about Shift SC and everything you guys are doing. I think in terms of my background, I have a PhD in operations research and information engineering, but a lot of people haven't heard about operations research before. So one way I like to describe operations research, it's really about applying mathematical modeling and thinking and analysis to all different kinds of real-world problems. So I think that mix of technical analysis while also being very closely tied to real-world problems and always trying to go back and forth in between what could be interesting to a real-world practitioner versus what is kind of like technical or fundamental about the problems that people are facing has been really interesting.
That's super cool. I'm sure this is super relevant to everyone watching this podcast today. I'm sure a lot of people do not necessarily know a lot about operations as it's a very niche and also very relevant field. If you were to just describe it in a very simple way for a non-technical audience, how would you describe this?
Yeah, I think it's a mix of technical thinking in terms of engineering. You might imagine like algorithms or optimization, but really applied to thinking about real world processes.
Yeah.
So, how do you go from maybe like a very complex description of how everything interacts
Okay.
to really a simpler maybe like flow-based model of like what's the key things that impact each other. So you can imagine maybe like a scientific perspective thinks of like the world as like all these interacting particles, and
Yeah.
operations is really trying to go to like a higher level and figure out like what are the key levers that are pushing and pulling against each other that we need to understand to make better decisions.
That's super cool. So it seems like it's very relevant to pretty much any field that involves, or maybe even doesn't involve technology at all. So especially right now with the rise of AI and also large language models and agentic models, do you see a role for AI in operations research, and just in this field in general? Like, what are your thoughts on the uses of AI and like the applications?
Yeah, absolutely. So I think AI and operations research are very intertwined.
Mm.
There's definitely people out there who, if you ask them this question, we'll go back and forth back to people from like the 50s and 60s where these two things were very, very closely tied. But I think there's a lot of natural areas of overlap. One of the biggest ones is probably decision making under uncertainty. So
Okay.
very classical AI was all about thinking about how do you train agents or intelligent agents to make better decisions under uncertainty.
Yeah.
That's also very core in operations. And operations also thinks a lot about trade-offs. So obviously, if you had no resource constraints, you could try to optimize, to the end of the world. But
Yeah.
we always have we always have resource constraints, we have data constraints, we have compute constraints. So how do you really strategically move in a world where you're constrained by resources, data, compute, and so on?
That's interesting. When you mentioned that it's kind of like working in uncertainty and also when there's like limited resources and limited time, this also reminds me of like the principle of economics where like everything runs under the concept of scarcity. And would you say that economics is also a big application of operations? And do you think there is a lot of scope in econ for this, or how do you
Yeah,
see
absolutely. That's another huge pillar that I haven't necessarily mentioned yet. You
it?
can think about it as kind of engineering meets economics, but
Yeah, yeah,
economics is super core to operations as well. I think one of the big distinctions that I like to make between engineering and economics is economics, for example, might tell you what price to set,
mm,
or might inform like how do you try to what's the best balance of supply and demand. What operations will be doing is really kind of working behind the scenes or thinking about like with all the levers or like with all of your complicated like supply chain, how do you
yeah.
actually make that happen?
Okay, okay. So all the logistics,
Yeah,
like planning all of that, that
yeah.
makes a lot of sense. So speaking about AI, looking ahead around 10 to 20 years from now, let's say, what excites you the most, and also what concerns you the most about the role of AI in human decision making, especially in this field, or even just outside of this field? Just your general thoughts on AI.
Yeah, that's a great question. So I think what's really exciting and scary for me is might almost be the same thing, which is that AI is really everywhere.
Yeah.
So previously, I've worked on topics like algorithmic unfairness or humans in the loop.
Mm,
And in those settings, we were often thinking about very high stakes decisions.
okay.
For example, like a judge being shown an algorithm or like a doctor getting algorithmic advice.
Okay.
And I think a lot of people, I think that um, a lot of people might have thought of those situations as very different from the day to their lives. And
Okay.
obviously, like we're not all doctors and judges, but
Yeah.
we now all live in a world that is full of AI information.
Yes, definitely.
So we're actually now all humans in the loop of like a kind of giant sea of AI information.
Mm,
And so these questions of how do you figure out what to do when you're given unreliable AI information, I think it's questions that we're actually all facing right now.
absolutely. Yeah.
And I think that is what is most exciting and scary. There's a lot of promising impact from there. But these
Mm.
questions about reliability also become very important because now everyone is the human in the loop.
That makes so much sense. I would totally agree with that as well. I think right now there is just so much AI everywhere. It's applied in pretty much any field. Students are using it all the time. Professors, I know one of my classes right now, my professor even incorporates like AI into our assignments and like has us do for example, like homework assignments where we compare AI's response versus like the textbook solution. And I think it's super interesting. Like, this is most definitely, like you mentioned, something that we all struggle with. And speaking of students and of AI as well, a lot of students right now see machine learning as just building models. But your work is more about decision making specifically. Am I right? So, what's the difference and why does this matter?
Yeah, that's a really fun question. So, the difference between predictions and decisions, I like to think about it in two ways. So, sometimes a single prediction is not necessarily enough to make a decision, but
Okay.
the flip side is also true. So, the fact that you're trying to make a better decision can also help you cut down on what you're trying to predict. So,
Okay.
it helps
Yeah.
you narrow down like what exactly is the information that you're looking for. So, one example of how prediction is not enough, for example, I think a very nice example like this is comes from something that we talk a lot about in class, like the news vendor example. And I think the basic idea here is if you're trying to make a decision about what you should do in the future, and there's some uncertainty about what's going to happen,
Yeah.
as long as your kind of like loss function or penalty or like the bad stuff versus the good stuff
Okay.
that happens to you, as long as there's any asymmetry in, the upside or the downside,
Okay. Yeah.
you,
Like one side is more than the other.
yeah, yeah, then you start to need more information from your prediction to make sure that
Okay.
you're going to get good decisions.
Hmm.
So what's an example of this? For example, I like food. So if we think about like bagels, or like a
Yeah.
bagel shop, for instance, they're trying to understand like how many customers they're gonna have.
Yeah.
And
Okay.
so the upside of them having bagels on hand is that they can sell more bagels and make a lot more money.
Yeah.
The downside is, they lose inventory, but they're baking a lot of bagels at a time, so their marginal cost is maybe lower.
Okay. Yeah.
And so then this is very common. So once a business or a person starts to have asymmetric upsides or
Okay.
asymmetric
Yeah.
downsides, you start to need more information about your prediction.
Mhm.
You need to understand what's the probability that I'm going to see like more customers on average. And so if you think about it, the world really relies on this kind of reliability. So if you go to the
Yeah.
grocery store, they're not out of stock 50% of the time. You'd be pretty angry if,
Yeah.
yeah, if,
Yeah. Right.
yeah, if
Yeah.
everything you were trying to
Yeah.
do was successful 50% of the time, you'd be pretty unhappy. And the reason that that's possible is really because we have more information about what's the probability of rare events. And we
Okay.
can
Okay.
take that extra information into account to try to make sure we're covered in 90% of our scenarios instead of just 50%.
That makes sense. That makes sense. Yeah, especially when you brought up the grocery store example. Yeah, it's very rare to notice that they're completely out of stock or like they don't have something. So that makes sense. I guess it's super pressing in feels like that where it's like more about the reliability than and consistency.
Exactly. Yeah. That reflects someone's making a decision that is
Mhm.
different from, just thinking about like the expected number of customers that
Yeah,
come in.
makes sense, makes sense. And speaking of reliability, a lot of your research focuses specifically on making data-driven decisions to increase reliability, especially under uncertainty, which is exactly what you mentioned. So, for a lot of our audience who may not necessarily be technical, what does reliable actually mean in the real world, especially in this context?
Yeah, that's a huge question. I think maybe a high level way to think about it is what extra information can we tell you or what guarantees can we give you about a prediction
Yeah,
so you can understand when you should go with it or rely on
okay.
it or kind of trust it, let's say.
Yeah,
So, an example of this is this idea called calibration. So, if you are checking your weather app every day, you want they're going to give you like a probability forecast, like a chance of
yes,
rain.
yeah,
And what reliability means there is that that chance of rain actually reflects the chance of rain that you would
yeah, it
see.
should be accurate. Yeah,
Yeah, it should be accurate. If it says there's 80% chance of rain, hopefully, 80% of the days that it says that, it rains.
yeah. Though
Yeah.
sometimes it's
Yeah,
sometimes it's errored.
exactly.
Yeah.
Yeah. It's hard because for every, context, you only get to
Mhm.
see kind of like one random realization.
Okay,
Yeah.
that makes sense. Yeah, I think this gets me thinking, and I'm sure all of you can relate to this as well, but something that is a hidden superpower of a lot of businesses and a lot of these operations is the fact that they are reliable and that no matter what, you can pretty much most of the time rely on some specific outcome. Like she mentioned the grocery store example. I think this is super important. I think that's such a cool takeaway from your research. And everyone should know more about this, especially in the tech space. And so you also work at the intersection of ML and causal inference. So, why is understanding cause and effect specifically so important in today's AI systems with all the AI that we have accessible? Why is it so important right now?
Yeah, so that's a great question. I think cause and effect is something that is unfortunately not as standard taught in kind of machine learning as it could be.
Mhm.
So maybe I'll start with why cause and effect is important for actually making better predictions
Sure.
if you're going
Yeah.
to use them for decisions. And I think one big reason is that all of the data that we have in the real world,
Mm.
usually it comes subject to all the processes that like an organization or a business has already been conducting.
Okay.
And what that means is that there's kind of going to be causes and effects lingering in the data that we already have. And
Yeah.
so we want to make sure that what we're predicting is reliable. And a big threat to reliability is actually the way that historical data can reflect these kind of idiosyncratic things about how
Mm.
businesses or firms do things.
Okay.
So, one really kind of interesting example about this is this example of pneumonia risk prediction. So, a healthcare setting. So, this, on the one hand, sounds like a fairly standard task. Like you have a lot of healthcare data, you want to predict who's at risk of pneumonia. So, you take their data from the electronic medical record,
Yeah.
feed it into off-the-shelf machine learning, and predict, 0, 1, what happened to their pneumonia. So what these researchers found is that actually their prediction model was suggesting that a patient with asthma would actually be at lower risk of pneumonia.
Interesting.
Which
Okay.
doesn't make sense medically, right?
Yeah.
Yeah.
Yeah, I would have
it
thought the
doesn't.
opposite. Yeah,
Exactly.
yeah.
And doctors would have too. So this was very
Okay.
troubling for them. And this actually would have blocked the deployment of the prediction tool because the
Yeah.
doctors saw this and were like, wait, this doesn't track.
Yeah.
Like I'm not, they were like,
Okay,
well, if I see an asthma patient, I'm not going to withhold treatment for them because this prediction model said so. So these researchers did a little more digging, and they found out the reason that this showed up in the prediction model is because at this hospital previously, the patients who had asthma were admitted to a separate unit, and they were given like a different level of care.
Oh, okay.
So, the doctors knew that they would be at higher risk, so they actually took extra care of them
Okay.
to make sure that they wouldn't get pneumonia.
Okay.
And so the prediction model, they didn't know the story about how people were doing things,
Yeah.
what goes into the data. And so it just sees the relationship, the predictive relationship after all of this.
Okay.
And so
Makes sense.
the story is, I think, more the case than not when we're working with data from like real world firms, like businesses, hospitals. We just have data lying around.
Yeah.
Most people work with the data that they already have. They don't necessarily like build new petri dishes
more.
of data, essentially.
Yeah.
Yeah. So there's going to be all these kind of historical causes and effects in the data that we're working with. And you don't want to kind of naively bring that forward into your future predictions.
That makes sense, especially because now I feel like everything is pretty much tracked. There's data on everything that companies already have. There may be some missing pieces that they still need to collect to make the most accurate and most useful predictions, which actually leads me to my next question. So there's currently a growing concern with the fact that all these models and especially the algorithms can reinforce a lot of bias, as you just mentioned, like there was that missing piece about the other separate hospital ward. So from your perspective, what are people getting wrong about algorithm fairness and what are they getting right? Is there anything that our audience should know about bias in algorithm that they may not already know?
Yeah, this is a great question. I think lately we've seen a lot more normalization of the idea that we should be concerned about algorithmic fairness or differences in models.
Yeah.
And I think that's been really exciting to see that it's not just run the model training process and deploy, but actually check it before deploying.
Yeah, definitely.
So that's been really great to see. Some things that I think people are getting wrong, it goes in both directions, actually. I think that sometimes people think that algorithmic fairness maybe doesn't apply to their setting, but I think it's actually very
It's
broad.
always, yeah.
Yeah, there's just something about the fact that these models are minimizing loss on average. And so they're always going to miss some tail cases, or they're always going to miss.
Absolutely, yeah.
The world is just filled with difference in how everything happens.
Yeah.
So on the one hand, I don't think algorithmic fairness is like this necessarily kind of like very particular. It's not. It's actually much more generally applicable just because models try to minimize average loss. And you want to have stronger guarantees for a single person than just saying like, oh, like the loss was good on average on like 100,000 people, most of whom have like look nothing like you, let's say. So you want to be able to provide stronger guarantees to an individual person that these predictions are reliable for them.
Okay, so it comes back to the same important theme of reliability, which is amazing.
Exactly, yeah. Algorithmic fairness is one way in which a model can be reliable.
Yeah. So you mentioned one way. Are there other ways that you think are very important as well?
Yeah, I think they're very closely tied. So so it only comes down to what you're trying to do with the model. Like what kinds of decisions are you trying to make?
Okay, that makes sense. Now going back a bit to your background a little bit more, Was there a specific moment or project where you realized this is what I want to work on? And the reason I'm asking this is because, in case you guys don't know, Professor Angela Zhou right here has a lot of experience across a lot of different papers, a lot of different fields. So, is there a specific one that you have an attachment to, and why? And what would you like the audience to know about that paper?
Sure, yeah. So maybe one paper that is indicative maybe about some of my first works in the area of kind of like technology and society in
Yeah.
particular is a paper on residual unfairness,
Okay.
kind of like thinking about bias in, bias out issues. And I think it was really going to an early kind of fairness and machine learning workshop
Yeah.
where I learned that these machine learning tools were being deployed in social systems in the first place.
Okay.
And that was something that was quite surprising or new to me
Mm.
because the way that I learned about machine learning and prediction was with fairly standard data sets,
Yeah.
like the iris data set, like what color flower is this? Or
Yeah.
yeah, I think it doesn't feel tied to decisions of consequence necessarily
Okay.
when we learn about it.
Yeah.
And so if we just see like an average, like mean squared error, it's like, yeah, better is better. But I think it was seeing these prediction algorithms just be fundamentally not perfect.
Okay.
So I actually went to like a pre-engineering high school. So we learned a little bit about engineering and like CAD or like kind of like computer-aided manufacturing. And if we think about mechanical engineering, things are designed to just very like tight tolerances.
Yeah. Yeah.
But when we think about machine learning, this is a technology that is fundamentally not 100%.
Okay.
There's underlying noise in the world. And so how do we think about designing better guarantees around these fundamentally probabilistic or fundamentally not perfect information?
Okay. Makes sense. Makes sense. So a lot of companies are currently racing to deploy AI very quickly. What do you think are the risks of moving too fast without fully understanding the data or the systems?
Yeah, so that is definitely the case. I think that there's a lot of risks, especially when it comes to safety and just more generally reliability as customers. So
Okay.
customers are also getting a worse product on average.
Yeah.
The companies are putting out releases kind of because they have to for hype
Yeah.
because the data centers are so expensive. So I think that hype is unhelpful because many institutions feel the need to deploy the product to justify to sell more compute
Yeah.
or to justify to funders that they're incorporating AI.
Or they're doing something new.
Exactly, yeah. That they're doing something new, that there's innovation. Whereas really AI is not a 100% thing. It may or may not help you to come back to the economics of it. It can be quite expensive.
Yeah.
Yeah, just the other day I was working with someone and we were asking, hey, can we do this thing with LLMs? Can we like ask the LLM to do this? And the answer was we should use regex to do this.
Oh,
Or
okay.
something like that.
What is
yeah.
that?
It's like a very old school way to do like search on strings. So
Okay.
you kind of construct like a clever search query.
Interesting.
And yeah, you can like add wildcards and things like that. But it's this very old school thing.
It's not the modern AI.
Yeah, it's not
Yeah.
innovation.
Yeah.
But a well-designed
It's
regex
reliable.
will be like 99% reliable. And what we saw with the LM was that it was not there.
That makes complete sense. I think, especially in settings where reliability matters. I know we've touched on this specific thing a lot in this podcast. But yeah, I think it's super important that systems and models, and especially when it affects people, like releasing products, like reliability is such a huge consideration that maybe not a lot of companies or products are taking into consideration right now. And we hear a lot about AI being accurate, but not necessarily correct or fair. And do you really think there is a difference between being accurate versus correct or accurate versus fair? And I know we did mention bias and reliability more, but especially to like a more non-technical audience, do you think there is a difference? And how do you think people should think about that distinction when interacting with models on a day-to-day basis?
Yeah. So I think there are potentially differences, but to maybe go to a higher level,
Yeah.
I think that's how you try to measure like how good a system is ultimately depends on what you want to do with it.
Mm.
And therefore, there are many ways to measure aspects of a system's performance.
Mm.
But that's actually a good thing, not a bad thing.
Okay.
And so, you should have some idea of like what you want to do. And then there are metrics that will measure more closely relative to that what you want to do. So to give a concrete example of this, I think an interesting example actually comes up, for example, with like ranking versus classification.
Okay.
So in many kinds of AI and society problems, what happens is an algorithmic decision-making tool gets deployed to try to help someone like a doctor figure out like who is the top X percent of patients who's at risk for something. So let's say
Yeah.
they have like limited capacity, limited ICU beds or something. So you want to make sure that those limited beds are going to the people who most need it.
Absolutely. Yeah.
Yeah. So that turns out to actually be a ranking problem
Okay.
in the sense that you want to be able to sort which person is, more at risk than someone
Yeah.
else.
The sorting part. Okay.
Yeah.
Yeah.
And that actually has different metrics than, pure classification
Hmm.
accuracy, which kind of assumes that there's one decision threshold that the doctor is applying.
Interesting.
And
Okay.
so that's an example just of the fact that what you're trying to do with the system ultimately should inform how you measure what
Yeah.
good means.
That makes sense. That makes sense. And actually, we have a lot of audience on here who are potentially interested in the intersection of AI, policy, and ethics. And I know that is like an overlying broad theme that we've kind of touched upon. What skills or mindset should the audience of this podcast focus on developing if they're interested in this intersection? And I'm asking specifically because you have a lot of work that is in this specific area. Like you've done a lot of research, especially with things like bail reform and social programs. So maybe you can start with talking about that research and then maybe like advice to our audience on if they're interested in working in that area.
Yeah. So maybe if it's helpful to talk about kind of like how my own work evolved in the
Yeah.
realm of AI policy and ethics. Some of the first papers I worked on included studying the use of pretrial risk assessment algorithms in criminal justice. And the basic setting here is there's a prediction of how likely someone is to commit another crime.
Okay.
That
Oh, that's super
prediction,
interesting.
yeah.
So cool.
Yeah, and it's very strange, but these are deployed like across the country, and
Yeah.
they're all not that accurate.
Okay.
Like their
Yeah.
AUC is like it's like 60-70%. Like it's
Oh, okay.
fundamentally a social prediction problem. Like you're
Yeah.
never gonna be 100% accurate.
That makes sense.
Yeah, and then the question is, how do you better design metrics to assess how people use these algorithms, and how does the performance evaluation of these algorithms really reflect prior historical decisions?
Okay. Okay.
So I think what I found there is that there's a lot to gain by learning at least like a little bit more about how the real world process works.
Yeah.
I think you learn a lot about how the data was collected, about potential challenges or threats to reliability
Yeah.
that arise from that process. And it turns out that in the real world, these institutional factors are super important, kind of like first
Yeah.
order determining like whether improvements persist or not, really.
Okay.
Um, yeah, so that was a kind of like first line of works about measuring and measuring disparities.
That's super cool. I feel like if a product were to be built on something like this, it would be super useful and super applicable to a lot of institutions.
Yeah, and what's interesting is that a lot of institutions have already deployed
Hmm.
these simple prediction
Yeah. Yeah.
algorithms.
Yeah.
Um, this kind of social prediction is fundamentally noisy. And
Yeah. Yeah.
so it's very interesting to think about like how does that change how we think about machine learning
Hmm.
in a way if the color of the flowers was always determined from the very beginning,
Yeah.
but these kinds of prediction questions, the answer is not.
That makes sense. That makes sense. If you could change one thing about how the tech industry approaches data and decision making, what would it be and why?
Yeah, so I think actually, in terms of data and decision making, the tech industry has been a very interesting case
Hmm.
where randomized experimentation, A B testing, trying things out, it's all a little bit easier to do in the tech industry than in, let's say, like large scale social programs or like other
Yeah.
institutions or health or like, clinical trials are this really like important high stakes thing.
Yeah.
But
Yeah.
in the tech industry, if you're trying to assess like how do interface changes change how people interact with your website, that's a lower stakes thing. It's a little easier to rapidly iterate
Yeah.
on.
Probably because of the scalability, right? Yeah. It's
Exactly.
super
Yeah.
scalable.
Yeah. So I think actually one thing that could change that would be really valuable is
Hmm.
actually um, improving consumers' steerability. So
Okay.
I think people have always been kind of subject to personalization
Yeah.
in the sense that there's recommendation algorithms that work quite well. There's personalization that works quite well, again, kind of on average.
Yeah. Yeah.
But I think with technical capacity, um, consumers should actually be able to kind of steer their own experiences or
Hmm.
going beyond like
Okay.
customization and settings. I think this idea of steerability, or you should be able to tailor your recommendation algorithm, you should be able to kind of shape the way the content flows to you.
Interesting. Okay.
I think it's technically viable, and I think it would go a long way to, yeah, just improving people's experiences.
That's super cool. Actually, this reminds me a lot about how right now there's a big trend in the want for having technology and AI seem as non AI or non technology as possible, basically as seamless as possible, where it's like it doesn't even feel like technology. It almost just like it's just a part of your routine or a part of who you are. So, um, going off of your previous answer, what do you think this could look like in maybe let's just say for example an app or a product like having more steerability in the customer? What do you think that could look like in a product?
Yeah, I think you've hit on a great point. For so long, a lot of advancements in tech were about trying to reduce frictions, move
Yeah.
towards like a frictionless experience, the UX becoming more glassy,
Yeah.
yeah,
Liquid
smooth,
glass and
yeah, exactly,
everything. Yeah.
liquid glass. I think one example of this that is really cool is something like Blue Sky's protocol, where you can kind of build
Okay.
your own
Interesting.
recommendation algorithms on top of it. You can build your own feeds. And now in
That's
the
so cool. I haven't
exactly,
heard of this.
yeah.
Yeah.
Yeah, I recommend it because you can kind of build your own feeds, tell your own customizations. And now in the age of agentic coding and AI coding,
Yeah. Yeah.
this the technical skills required to do this personalization, hopefully we can go from kind of natural language descriptions from
Yeah.
a consumer's head and translate that into these technical protocols.
Okay. Yeah.
And therefore, that's why I think the steerability is really quite viable now.
That makes so much sense. I think we're definitely at a point where it is technically feasible, like you said. I think it's just the approach when it comes to building and creating new useful products for everyone. How can we make technology as one, reliable, and two, personalized, and three, like steerable as possible? And I want to end with a very fun question. Maybe all of you guys can hear something very interesting about her. What's something that you believe about technology and society that you think most people would disagree with? So, in other words, what's your hot take about technology?
Yeah, so I think maybe one opinion that I have about technology and society is that actually we can learn a lot by like going outside and learning from like what people are trying to do without technology, and that can
Interesting.
inform like really what we're trying to do with technology. And
Okay.
the flip side is true too. Like what I want from technology is to just let me go outside more and not be at my desk or at my laptop all the time working on things. So I think
Yeah.
moving towards that is the ideal.
I think that makes so much sense. Actually, like that's how we could probably get to a future where technology just integrates with our schedule and just integrates with our day-to-day life. I think right now AI is not necessarily being used in the most optimal way. And if we can get it to just integrate with our current existence, with our current schedule, and make it not replace us as people, but rather just aid us as a tool, I would say once we get to that point, I would be pro AI. But until then, my hot take is that I'm anti AI.
No,
I think,
I think that makes sense. Yeah, yeah. It's like I see demos of people like writing poems with AI, and the thing is, I would like to write the poems. I would
mhm.
like AI to do my laundry, so I'm here for
Yeah,
a laundry
right
AI
now the
dishwasher world.
Tesla, the humanoid coming out.
That's true. Yeah, we might be
Yeah.
getting there.
But yeah, well, thank you so much for this conversation today. It was really enjoyable learning about your experience, about your research, and I'm sure all of you guys have a lot of great takeaways about reliability, bias, and decision making under uncertainty. Thank you so much for your time, and I'm looking forward to seeing you on the podcast sometime soon.
Thank you. This was super fun.